So next up, we have Cisco. We have Paolo. Sì. So we are finding presentation slides. So Paolo will tell us about, will bring an SDN story from Cisco. You can see the logistics committee at work. I mean, the chair.
All right, I will introduce myself as the presentation starts. So my speech will be a little bit less technical than the previous one. I used to be the Chief Technology Officer for Cisco Service Provider segment from 2009 to 2014. Then I had a crazy idea to move from Chief Technology Officer and Architecture to try to sell the stuff we design. So I'm now leading the business for service providers in Italy, both the big and the small ones in country for Cisco. And actually, when I go back to my earlier days as a CTO, I still remember when software-defined networking started becoming a big topic. Those were the early days of OpenFlow, and decoupling the control plane from the transport plane, the data plane from the control plane. What can be done with that in terms of both network flexibility, in terms of reducing the cost base, in terms of network programmability. So at Cisco, is this the right clicker? This one, right? Yeah. We try to basically think about what could be the implication of adopting software-defined networking in the three macro domains of a system: data center, transport network, IP network and optical, and user network, be it enterprise or small, medium business. And actually, I have to tell you now in 2017, if I look behind, most of the efforts in the data center, when I think about software-defined networking, was about implementing an agile way to configure the data center in terms of policies. If you think about the implication of SDN in the data center, it's on the one side, simplify the logical topology, move more to an overlay model for networking. On the other side is to apply policies in a way that when you start deploying applications in the data center, instead of dealing with subnetting, VLAN, VXLAN, and so on, you have a simpler way to map application attributes and policies to what is cascaded down into the data center. When I think about the wide area network, the transport, a lot of the efforts have gone into primarily how can I steer traffic in the wide area network based on application criteria, application preferences. And this is still pretty much the key focus. Of course, there is a high degree of automation in play when you deal with SDN in the wide area network. But if I have to look at what is driving the use cases, what is driving the relevance of SDN in the public network, it's still primarily about making better use of traffic management and steering traffic flows across the network. When I think about enterprise networking and user, we call it intent-based networking. If you like, it's still about making the network, self-configuring itself and adapting faster to changing policies than by doing manual configuration. Ovum, as a research analysis, when they say, you know, what is driving SDN in the market, they say primarily faster service velocity and reduction in OpEx. When you think about that, it's again a combination of what I mentioned earlier across the three domains, data center, wide area network, and enterprise. Now, looking at the service provider experience, and I think about big implementations of, they are fundamentally based on software-defined networking, and they start bringing tangible results in terms of economics. I think about TerraStream in Germany, where we started about 4 or 5 years ago. I think about what we're doing with smaller providers, more like city carriers. There are a lot of commonalities, and there are basically 3 key ingredients that bring SDN to fruition and SDN to bring some economical result. One is about simplification. So using SDN to basically supplement or complement what we call delayering. The speaker before me mentioned, you know, what happens when you start having a break in the optical link and you have black holing in the IP domain. Well, a way of trying to circumvent that issue is by having the control layer in the IP domain and the optical domain having almost a constant dialogue, right? You can have basically a controller, an SDN controller in the IP layer, an SDN controller in the optical layer that implement what we call multi-link restoration. So at the very point in time, your SDN optical controller starts seeing high error rate on the link, going from yellow alarm to red alarm. Instead of putting the link immediately out of service, it starts flagging the likely unavailability of the optical link to the IP domain, and the IP domain starts basically rerouting around the BGP, using the BGP logic around the link about to fail. So instead of having a brutal tear down of the optical link, you start working in a coordinated fashion between optical and IP. And that's the key ingredient to do what we call delayering. Okay, delayering doesn't mean only to eliminate SDH layer when you start transporting IP packets over optical. It's actually about integrating the control planes of IP and optical so that you make a smarter use of optical capacity from an IP perspective and a smarter rerouting around point of failure. The other key ingredient, when I think again about big and smaller deployment, has been about automation. So the very nature of SDN is not only about decoupling control plane from data plane, it's not only about using open flow as a way for the controller to tell packet in, packet out, all right, drop a packet or forward a packet to a given direction. The very nature of SDN is also to expose northbound APIs that allow to abstract the complexity of the network and program the network routing logic. So the ability to automate a network provisioning lifecycle or a service lifecycle is intrinsically bound to the ability to program the networking layer, be it IP or optical. And virtualization. Virtualization, quite often I read on, let me say, marketing press, SDN/NFV. Doesn't mean a lot. These are intrinsically 2 different things, right? NFV is about, you know, virtualizing layer 3 to layer 7, if you like, and run on virtual machine and hypervisors. But in reality, those 2 ingredients tend to go quite often hand in hand because they are part of the same effort to simplify and make better use of logical and physical resources in the network. I'm taking as an example here, as an example of how use cases around SDN are bringing to some tangible results. A significant service provider in India, I cannot mention the name, but I mean, I think if you think they are headquartered in Delhi and they're a significantly large one, you can probably guess who they are. Well, this provider has 82 million subscribers, 82.5 million to be specific. They have a revenue per year of about $3.5 billion. And a gross operating income of about $1 billion. So 85 million subs with 3.5 billion revenue. You think about a national player like Telecom Italia. In Italy, I think they have about $15 billion or euros of revenue, okay, with 22 million subscribers. So there is a factor here of more than 10 in terms of reduction of ARPU, and they still generate out of $3.5 billion revenue, 1 billion of gross operating profit. What does it mean? It means that, and they buy, by the way, sorry, Cisco routers, Juniper routers, Arista from the market. They're not building routers themselves. It means there is a way to run those networks with a substantially optimized cost base compared to anything we're used to do. Okay, and if they made a bet in India on this super large scale, hyper optimized network in terms of the cost base, Of course, is on CapEx, but it's primarily on operations. One of the key challenges for them, this network is hyper-growing, so they had to deploy routers, they have to configure routers real time, they need to have basically what we call zero-touch provisioning. One of the big bets was actually to basically get the machine out of the box and try to have it up and running, some sort of pre-configuration, but also a lot of real-time verification with SDN visibility, SDN programmability in 40 minutes. Router deployment took from 5 days in the initial phase out, in the initial rollout of the network, to 2 days. The use of SDN there was not so much to do traffic steering, was to basically probe the configuration of each element in the network almost real time and have MOP, method of procedures, then can be adapted with a velocity which is still very largely unknown in many of the European implementation. The additional value that you have with SDN configuration is that then once the network is deployed in terms of day 1 and day 2, you can orchestrate abstracting the network complexity. So they also built a model fundamentally built on netconf and YANG, so using YANG as a service description language and netconf as the protocol to communicate with the network element to abstract the complexity. And once the network has been kind of pre-provisioned and real-time check in terms of SDN probing of the configuration, they also use network lifecycle orchestration to move faster in the network, network provisioning. The next round of development we see based on that model is not only on using SDN as an element of programmability of the network and fast inquiry of the network, is also using that ingredient together with streaming analytics or real-time analytics. I've heard before in discussion about syslog being a pretty old protocol. You have a lot of other sources of information that are pretty old in nature, like SNMP. You start having, NetFlow, sample NetFlow in routers. You have the more sophisticated way of stream data to any sort of data lake or database. Fact of the matter is that you gotta have to make sense of those data. So there has to be a need. There has to be a way to do trend analysis, deduplication, and correlation. Once you make sense of those data, there has to be a way to basically map those weak or strong indicators into actions that are then cascaded back to the network. What I'm trying to say with that, very basically, one of the next use cases is to start pulling together streaming analytics from the network, sample NetFlow whatsoever, and network programmability with SDN is the overall notion of predictive maintenance. Imagine you start having anomaly behavior at link level, IP level, BGP level. And you based on past performances, you understand the certain symptoms that your network is streaming to you in terms of data can be correlated and can be mapped on something bad happening in the network. At that point in time, you can use the orchestration layer to basically reprogram the network behavior before something wrong happens. So it's kind of a closed loop model where you use on the one side streaming analytics, on the other side correlation. There are very basic tools to do correlation together from either open source community or vendors like Mugsoft as an example. And then you use programmability, SDN, again, and netconf YANG to drive the network behavior based on that. The mantra, I think, is to, I don't know whether there is anyone from Netflix in the room. I see Netflix is a sponsor. I don't know whether this reflects the reality in 2015. Our finding is that to operate your network, you had less than 10 engineers. In 2015, now things are probably a little bit bigger. Today, yeah. Yeah. We're still discussing about probably 1 or 2 orders of magnitudes compared to, let me say, yeah. And same story for Facebook, but even same story for Iliad and Free, that, by the way, is about to open facilities and services in Italy. I remember the first time I used to visit Free in Paris, they were operating the whole thing with less than 20 engineers, network engineers. So that's the mantra. The question is, how do we get there? And that's the other extreme of the spectrum, if you like, right? The target is what we have here. The starting point is large operation. This is a model we developed with a large Italian mobile provider. You can guess who they are. And there are several elements in using SDN network function virtualization that help drive costs down. And if not reaching the mantra, the holy grail of a Netflix or a Facebook, at least reduce substantially the cost base. One element that we model with them is the ability through automation to simply reduce the number of full-time employees, simply reduce the cost of labor in terms of number of hours to do the same operation from manual to semi-automated. The other element that we see is the value brought by virtualization. And to our surprise, network function virtualization is bringing less economical savings than the full scope of automation. Actually, what we found with NFV is elastic use of resources, computing, of course, better resource pooling, when you start having either microservices or virtual machine running on the same piece of bare metal, flexibility in use of resources, less power consumption, less real estate. These are probably the 4 fundamental drivers. When you pull them all together, at least in this macro size example, the savings that you get are less than with automation on basic operational procedures in managing the network. So the driver, the strong driver, when I think about use of SDN and NFV, is more automation than virtualization itself. Normally, between this end state and the complexity of large operators that have to basically streamline operation and make better use of SDN and NFV, there are some intermediate cases that are very, very practical. A use case that has proven itself particularly successful from the get-going in terms of deploying software-defined networking has been the ability to drive bandwidth based on application need. Sometimes it was related to application directly interacting with the control plane of a routed network, basically steering flow of traffic based on application logic. If you remember the advent of algorithmic trading in financial institutions, quite often the ability to do algorithmic trading was related to the latency between sending a command from an application and receiving the command on the proper server in the data center, transversing a network. So the ability for the application to say, not only I want to have the least cost path to go through the network, but I want to go through a path which is qualified for explicit SLA, was a discriminating factor in making that application successful or not. So I remember even before SDN, we started exposing programming interfaces, APIs from DevNet, to basically allow the application to call directly into the forwarding information base tables of the routers to steer traffic. A little bit more sophisticated model was to combine that with some sort of a scheduler and have basically bandwidth on demand as a use case fundamentally built on SDN. The other set of use cases, and these are probably a little bit more futuristic, but are related to how can you automate deployment of Internet of Things by trying to not only speed up the configuration cycle, but also to remove as much as possible control plane and intelligence, if you like, from the endpoints and centralize that control plane into what we call fog computing, which is basically edge distributed computing. One of the reasons why we want to remove as much as possible the service logic and the control plane from the myriad of IoT endpoints is related to security. Okay, you know that many of the vulnerability attacks from connected things come from the fact that endpoints are IP addressable, but from a security perspective, they are normally extremely weak. If you try by connected thermostat or connected camera, they are pre-configured with username and password admin. If you remember, one of the largest DDoS attacks in November last year was actually concerted by aligning traffic generated by connected things, thermostat and webcams, that were basically crackable because they had zero protection from a security perspective. So if we start depleting those endpoints from intelligence and we put intelligence into mobile edge computing, we work in the direction of securing the IoT. Now, to do that, of course, we need massive configuration, and this is where, again, SDN control, in terms of decoupling control plane from transport and in terms of automation, comes into the picture. The other key use case is related to automation of enterprise networking. I think I was having a discussion before with some of your colleagues here in the audience. What is the demand for, especially in Italy, for small, medium enterprise in terms of going over and above the classical connectivity and managed security demand in terms of networking? One of the key drivers we see is the ability to basically connect to anything which is IP connectivity, be it managed or unmanaged, i.e. VPN or the big internet, so to say, and have a way to configure their local area network environment from the cloud. That means intrinsically you take the LAN environment of a small-medium customer, small-medium business customer, and you move the control plane of that LAN environment in the cloud. And you start using SDN as a paradigm to do remote provisioning of the LAN or the access CPE whenever you have an element of IP connectivity. That's a very familiar use case when you want to basically enable small-medium enterprise to self-configure, to have an access portal, and still take the control of their local area network in the cloud rather than having that on-premise. SDN is the ingredient there, is the ingredient both in terms of SD1, so define the routing logic of those endpoints over the big internet, but also in terms of creating remote configurability, remote manageability of the small-medium enterprise networking environment. Now, with this type of picture, I think the two major challenges we see in front of us as a vendor, or I would say in general in the industry, are the following. With the advent of virtualization in the telco environment, with the advent of SDN programmability in the IT data center, both for internal IT consumption and to produce application to the end user market, the key question is what is the level of convergence across these three data center stack? The telco cloud, where you host virtualized network function. Is it better? No, still scrambling? Okay. One is the data center where you host the virtualized network function. We call it telco cloud data center. The other one is the data center, quite often where you run internal IT application for internal consumption. And the third one, logically speaking, is the data center where maybe you host customer-facing application or customer-facing services. And maybe for smaller providers, of course, there is already a level of convergence simply driven by economics. For larger providers, these are three different silos. The key question is, what is the expected level of convergence in the data center among those three silos? Clearly, the drivers in terms of bare metal, in terms of hypervisors or microservices, in terms of even gigabit connectivity are very common. So logically speaking, there is a way to pull those three data centers together and create some economy of scale. On the other flip of the coin, the level of automation required, the level of application visibility required in those three different types of data center are intrinsically different. So this is still, I believe, an unresolved point in the industry. What is the speed and the level of convergence between something that has been originally designed for internal IT, something which is now flourishing and is being designed for telco cloud functionality, where you virtualize your firewall, your layer 4 to layer 7, and something which is optimized for fast application deployment that are rolled out to the market. What is the level of convergence and what is the economy of scale we can achieve without compromising performances and manageability in order to optimize our cost base? That's one big challenge we are facing as an industry in the overall constellation of SDN and FV. The other one has to do with 5G and network slicing. Again, very much related to the integration of optical and IP. There is a lot of talk in the industry, a lot of discussion about network slicing, right? About the fact that with 5G, you're going to have virtual partition of packet core, virtual partition of IP transport, virtual partition of optical layer, so that logically, in the 5G environment, every business will have their own slice of both control and transport. The reality is that while you can do certain things in a pretty logical way, when you start abstracting the packet core control plane from the data plane, when you move down into the stack, so when you move into the optical layer, those type of logical partition becomes a little bit more complex to both implement and operate. So I think some of the challenges that the industry will face in the next couple of years in the journey to 5G is actually how can you create a family of controllers, going back to the SDN discussion, that allow to logically drive your logical slice of a network, be it a mobile packet core slice, with consistency with your logical slice of the IP layer and the logical slice of the optical layer. So how can you have multi-domain controllers? In this case, we call it basically optical VPN controller, where actually if I do a resource carve-out for 5G, that resource carve-out is mapped into IP capacity and optical capacity. The industry is moving that direction. I think that would be probably the next frontier in terms of creating monetizable and viable use cases built on the key ingredients of SDN, network function virtualization, and automation. Again, I apologize if I went a little bit fast with this type of, overall vision on how to make sense of network automation, programmability, and virtualization. I've been deliberately high level. I didn't want to go into details where each of those would probably require an ad hoc session. But I hope I gave a flavor of what it took to basically materialize some of the logical benefit of SDN in terms of transport, control, separation, in terms of programmability into use cases that make sense for the industry. With that said, how am I doing in terms of timing? Do we have time for a few questions, or if any? So time for questions or to shorten the session itself, as you prefer.